Alright, so in this video we're just going to look at how you might go about finding the coordinates of the turning points of a function. So the function we're going to look at here is on the screen. It's x cubed minus 3x squared. And just visually we'll have a look at what this function looks like. So if I just draw in a really wobbly axis, our function is cubic. It comes up, touches here, turns and then goes away. And so what we're looking to do is try and find the coordinates of these turning points, in other words, right there and around about here somewhere. And visually, it's really useful to picture this. So if we just come down below and we're going to do a sketch of the gradient function and what it might look like. Now you can see at there's 2 points that I've highlighted with the messy scribble. Those are the turning points, and at that turning point it will have a gradient of 0. So if I just bring this down, down to here, there's that point. This one can come down here. Those are our 2 points where this function will have a gradient of 0. And if we wanted to complete this curve, you can see that it is sloping upwards before it reaches this, so it has a positive gradient. It is sloping downwards, so it's a negative gradient in there. And then it slopes upwards, positive gradient there. So this is our gradient function. So right now this is y, and this is y dash. Now, hopefully it's fairly clear from this then, to get the turning points, what we're trying to do is, if we come down to the bottom here, we're trying to find where our gradient function, y dash, is equal to 0. And that will give us our turning points. Or at least it will give us the x coordinates of them. So, to complete this example, if we just come over here on the right, if we actually differentiate that function, so it's going to become 3x squared minus 6x, and all we have to do is solve this for 0. So we just make an equation and we solve it. So we can factorize that, 3x, x minus 2, which gives us two solutions. X is either going to be 0 or 2. Now that is the x coordinate of our turning point. So on our original function, this one here, the first one, is at 0. This second one here is at x equals 2. And so if we wanted to then get the coordinates for it, we would take the x coordinate and put it back into, up here, the original function. So if we just put 0 into there, we're going to get 0 cubed minus 3 lots of 0 squared, which is 0. And if we put 2 into the function, we're going to get 2 cubed minus 3 lots of 2 squared, which gives us 8 minus 12, which is negative 4. And so what this means is our two turning points sit at 0, 0, and 2, negative 4. And that is a quick overview of how you would find the coordinates of turning points for a function.